Hello, and welcome to SETI Live. I am your host, Beth Johnson, Communication Specialist here at SETI Institute, and I am joined by
Franck Marchis.
Franck Marchis.
She doesn't remember my name. Starting well.
Starting off 2024 well. Thank you to our viewers for joining us from around the world. Let us know where you are watching from, please. And welcome to listeners of our SETI Live podcast, which can be found on most podcast platforms. So it's 2024. We have arrived. We survived 2023, and now we're going to look forward to some new events, some special happenings. There's a lot going on.
We're going to talk about space, right? Only space.
We're going to talk about space, definitely.
Right.
Yeah.
So first, a question we should ask our viewers.
Yeah. So hey, to everybody out there, what space event are you waiting for in 2024? It can be the Eclipse, it can be a mission, it can be some sort of science results you're looking forward to. Let us know in the comments.
And let us know why.
Yeah, definitely. So where do you want to start? Shall we start with the big thing?
We're gonna start very locally.
Oh, we're gonna start very locally.
Yeah. First,
Okay.
We should say that we are at the SETI Institute right now.
I know, we're actually together in the same room. This is
Same
look,
room.
I can actually touch him.
She's in 3D. I'm in 3D.
This is amazing.
It's amazing. And we are the SETI Institute, and this year is a very special year for the Institute.
Yeah. So on November 20th of last year, we kicked off what we're calling our 40th anniversary year. So we were founded on November 20th, 84. 84. That's not 40 years, right? That's only like 20. Yeah.
It's good. You're good.
Okay, good.
You're good.
So we're kicking off our celebration. There's going to be a lot of news events. We're going to do a lot of interesting coverage. We're going to look back at the history of the Institute, the science that has been done here. And hopefully we'll all culminate in a celebration in person in November. So everything's still in the planning, but that's where we're aiming for.
Yeah, so stay tuned. You're going to be able to see us, maybe come here at the SETI Institute, visit the Institute, participate to some events in San Francisco, in Mountain View, and maybe elsewhere.
Yeah,
we have a ton of ideas.
We have a lot of ideas. So keep an eye on all of our social media outlets, all 8 billion of them at this point. We are on every platform you can think of. Yeah. So it was founded in 1984 by Jill Tarter and Tom Pearson. It was basically exactly what it says, SETI Institute, the search for extraterrestrial intelligence, and working on the variables in the Drake equation. And then that became a lot more than just that.
So when I arrived, I think it was 16 years ago, with just the beginning of the Carl Sagan Center, we started doing here astrobiology specifically. So expanded basically the search to not only technological signals, but as well natural biological signals, searching for biological signatures of life on planets, on exoplanets when we discover them, etc.
Yeah, and a lot of work into extremophiles. I think that was one of the things that was really surprising when I first arrived about a little over 10 years ago now, that, there were all these different creatures we were finding that were living in extreme situations, high salinity, low water,
high UV,
high cold, very cold. There's a pink algae that lives on snow. These are things that we've discovered that are amazing, that show us that life really can be just about everywhere.
Yeah. So think about what we discovered over the past 40 years.
Mm-hmm.
What will we discover in the next 40 years?
Yeah. And
what will be the next big thing in SETI and in astrobiology?
And that's going to be a good chunk of our focus this year for what we're going to talk about is what we hope to see in the next 40 years.
So we have people joining us from various places around the world, in Denmark, in Amsterdam, in Washington, D.C.
Hello, Adam, all together. Hello, Broken
everybody.
Symmetry.
Chile, hola, ¿cómo están? This is a flag of England, I'm assuming, right? Yes,
I think
I'm good,
so.
yes.
Sweden
again.
Germany,
etc. Welcome. We are the SETI Institute, and we're going to talk about what you expect in the year 2024 in space.
In space.
So let's talk about space missions.
Okay. So we have we've got a couple that are on their way. So we have the Lucy asteroid mission, which Unfortunately, there's nothing scheduled for 2024. It's just in transit to the Jupiter Trojans. But we did have Dinkinesh last year, so
Yeah,
that was a
man.
lot of fun.
Dinkinesh was a big deal. I mean, we had a talk at the end of 2023 at the AGU
Mhm.
meeting that we organized, and they presented the result of the flyby of Dinkinesh. I mean, they discover a moon, and the moon is made of two lobes, and the primary has this weird color. I mean, there is a lot of things for this asteroid. It was very fascinating.
So we got a lot of data from it. So there might be some more results coming out
Yeah.
this year. So it's not that there won't be stuff coming from Lucy. It just might not be anything
New.
It
could be analysis of the data already taken.
And then we have the mission to Psyche launched. And so that's on its way to Psyche. And actually, I think there's some flybys going on of...
I don't know about that, so I'll let you deal with this. Congratulations for improvising, because I was not planning to talk about it. But maybe there is flyby. Psyche, while you're searching for this information, Psyche is a mission dedicated to observe and characterize the asteroid Psyche. Psyche asteroid is a very interesting asteroid because we think it's made of metal, so it could be the core of a protoplanet, and we're gonna be able to see finally the core of a protoplanet and see what it's made of, and getting some high-resolution pictures and flyby and spectra, colors, etc., of this interesting asteroid. It may be very different to all the other asteroids we have seen so far, because most asteroids we have seen are either icy or rocky. So this one is made of metal.
Yeah, so it's going to be interesting. You're right. I don't think there's anything that's going to happen in this year, but they did start doing some first images to sort of, make sure everything was working. So we might still see a few things from it, depending on what is in the area.
So the big elephant in the room in the year 2024 in the space missions is, of course, the moon.
The moon,
in my mind, the moon's going to be the next big thing. I mean, I said that last year.
It was pretty big this last year too.
Yeah,
but there's still more.
Yeah, next year gonna be much bigger. So we have the Chinese Space Agency is going to launch the Chang'e 6 lander. Is going to land in the polar south pole of the moon. And one thing I really like with this mission is there will be a precursor mission that will be a satellite. And the reason for that is because it's going to be on the far side, so they need to be able to communicate with the lander. So they sent first a spacecraft that's going to orbit around the Lagrange L2 point.
Yeah, it's called Kekwao-2.
Yeah, I try quick.
Kekwao-2, I believe.
You deal with this one. Thank you.
I'm sorry, my anglicized Chinese is not all that great, but so that's going to be the satellite, and it is scheduled to launch in May. So we're looking forward to that. And then
it's going to return samples, this one.
Is it? Yeah.
It's going to be basically taking samples and bring them back. And one of the reasons we like this area where it's going to land is because we believe that there is, we can see very fresh material of the moon mantle inside this crater. It's a very craterized area. He's going to land in the Apollo craters, to be specific, and he's going to bring some samples which are, we believe, fresh or will reflect what we have inside the moon. So,
and of course, the lunar South Pole is exciting for us to figure out how to land at, because that's where we're looking to build a lunar base, which leads us kind of to one of the other things that may
finally
happen, which is Artemis 2.
Yeah, I don't really like you talk about the Artemis 2. Go ahead. It changes so often that
it changes so often, and I am with a lot of other people. I don't exactly have the utmost faith that it will happen this year. But that is the plan, is that the Artemis 2 mission is supposed to launch this year, and we're actually supposed to go to the moon, not just around it. So, because we did Artemis 1, kind of went around and proved that, the rockets work.
Artemis 2 right now will go around the moon with human on board.
But it's going to have people.
Yeah.
So that's the next step is taking people on this, and I don't. We'll see. We'll see. So.
And what I prefer to talk about is the Eclipse missions. So those are privately funded missions. No, they're not privately funded. They're funded by NASA mostly, with private funding as well. And those are companies. So we have two companies at the moment in the US. One is called Astrobotics, and they're gonna launch the Peregrine lander on January 8th, very soon.
Very soon.
And this is a very risky launch because it's gonna be the maiden flight of the ULA Centaur.
Vulcan.
Sorry.
Vulcan.
And that's a new rocket.
Yeah.
With a new sort of propulsion system, and they're testing this with a Peregrine on board. So I wish them good luck.
Yeah.
Frankly,
it's always a risk to go on that first.
It's cheap, but it's risky.
It's cheap, but it's risky.
And then the second company is called Intuitive Machines, and they're planning to launch 3 or 4 landers this year, and the first one will be Nova C lander, and it will be launched by Falcon 9 in February if everything goes right.
Yeah, and it's been postponed a bit as they've been doing more testing.
Yeah.
So hopefully February it won't move again, and that would be really nice to see that one go off. And hopefully we'll actually have someone to interview for SETI Live.
Yeah.
On that mission. So
it's we don't know which one's gonna land first. That's the funny part of it, because Peregrine is gonna have a very complicated orbit. It will take several weeks to reach the surface of the moon, while Nova C lander is supposed to have a much direct orbit, like a 4 or 5 days. So maybe Nova C will land before Peregrine. What's important here is that this could be potentially the beginning of private industry reaching the moon. This is something we have done for our satellites. We now launch satellites. Most satellites are launched by private companies for multiple reasons: communications, observation of Earth, observation of space, etc., etc. Here we are basically kicking off the beginning of the privatization of the moon surface with those missions.
But it's not just the private missions. We also have Viper.
Oh, forgot about this one.
Yeah, don't forget about Viper. Viper is another robot that's landing. Hopefully, this one will be at the later part of 2024. And it's, again, also supposed to land at the South Pole. It's going to get a little crowded from the sounds of it. And it'll be a mobile robot, so it'll be able to move. It's not just a lander. And it has a 100-day mission using 3 different instruments and a drill to basically do some sample collection and analysis on board.
So yeah, Viper will try to find out how is the ice in the pole of the moon.
Yeah, so this goes back to those craters at the South Pole have permanently shadowed regions where we think water ice can exist and may exist and
is stable
and would be incredibly useful for things like bases and being able to launch and create fuel and that kind of thing. So
that's a very risky mission because it's going to be exploring some very cold area of the solar system, the coldest we can even have. And let's see if the rover survive.
Yeah, and I think there's a thing on it called Flashlight, if I remember rightly. And,
oh yes, there's Flashlight too.
Where it's supposed to be, something that will help keep things running. Be able to heat up a little bit. So, a lot of testing
and technological challenge on the moon.
Yeah.
Talking about technological challenge, I think we should mention that 2024 may be the year we have a lot of new vehicles to launch satellites. I mean, we have, we mentioned Vulcan from ULA, Ariane 6 will launch probably March, April, or June. We have H3, the Japanese rocket.
That's right.
And there is the
New Glenn
that from Blue Origin. So those are rockets that are important because they're testing new propulsion system. Some of them will be partially recyclable or reusable. We don't know yet. And some of them will provide access to space to countries that lost access to space. Ariane 6, for instance, will provide access to space to all the European nations. They lost that since the last flight of Ariane 5. That was more than a year, 8 months ago now.
Yeah. So that'll be good, and maybe we'll get their ExoMars mission back on track.
Exactly. So here we are. Let's talk about. Do we talk about all the space mission? I think
the only other one we got to talk about MMX. Yeah, MMX is an important one. That's the JAXA mission that's going to Mars's moons Phobos and Deimos. And it's actually going to collect a sample of Phobos and bring it back to Earth. So this is pretty exciting because we might actually finally have a firm answer on what Phobos is.
What Phobos is, yes.
So that's
It's a mission, a Japanese-led mission with
Mhm.
a lot of contribution from the German Space Agency, the DLR. They are the one who's going to provide the system to harpoon
Mhm.
and collect the samples, etc. So yeah, it's going to be a cool mission. But it's been launched in end of 2024, so we'll probably arrive around Phobos in 2025.
Yeah, and so it'll take a little bit of time to
Yeah.
get all of that sorted out, but it's better than waiting on Psyche, which won't get to
Yeah.
there until like 2029.
That's why it's
So-
cool to work on Mars and Venus, because you have way more missions and way shorter time.
shorter time frames to get
Yeah.
your data back, so that's nice. Yeah, so and then
And I
Europa
think
Clipper. Do we?
Oh, Europa Clipper. You heard about this mission?
A little bit.
It's something
maybe.
like he's going to observe Europa, right?
Yeah,
But
something like
it's
that.
so launch what? End of this year?
I think so.
They're doing the assembly right now on the JPL page. You can see the webcam, or you can see people working,
Mm-hmm.
and they're putting together the spacecraft. We hope to be able to go see the spacecraft. In fact, we're trying to get invited in March to bring to the room to see the spacecraft.
And we're hoping. I did see your note in here that you're hoping that we can do a SETI live from JPL for that.
Yeah.
That sounds like fun.
We may have to write a lot of letter to JPL to convince them, though. So get ready. And so in short, this is a spacecraft that's going to orbit around Jupiter, like we have done with the Galileo spacecraft in the 90s, Juno at the moment. But it will have something like 50 flybys of Europa and take pictures at super high resolution, because it's going to come super close to the surface at different area. And the goal of the mission is, of course, to understand whether or not there is a signature of life on Europa by characterizing the surface, the color, doing spectroscopy, etc. So it's a very important mission, because that may be the first mission that detect without ambiguity the presence of life in the deep in the ocean of Europa.
Yeah, those icy worlds with their subsurface oceans are a great place, and we're excited to be looking at that one specifically.
So launch is end of 2024.
October, yeah.
It will arrive in 8 years, if I remember, or something like this.
Exactly.
So it's a cool launch to watch, because then you remember in 8 years when you arrived around Europa that you saw the launch.
Planetary science, it's a long game, guys. Yeah. It's a long game.
Oh, wait, telescopes.
So yeah, obviously, JWST's been up for a year. And running and sending back data, and every month now is something amazing. Last month we had those amazing pictures of Uranus that came out with the rings and all of the moons. And if you haven't seen it, it's on our website. You can look at it in one of our planetary pictures of the day. And we also Euclid had first light at the very end of the year, released their first 5 science images, and they were mind-blowing how detailed these images were. You had to go and zoom in on them, but you could, and there was so much stuff. And so that's just in it's not even like it's not even in its full scientific data collection. That was just the first light. Let's take some images and see what we get. So that's going to be the next, we're going to have 2 major telescopes that are sending amazing images back like all the time. So that's going to be a lot of fun.
But Euclid will not send a lot of pictures, because Euclid is kind of a survey telescope.
Yeah.
So it's going to be taking a lot of very deep pictures of the deep sky to detect those tiny galaxies. And this is not my field, but the idea is to characterize the color, the redshift, and of those galaxies, to get some idea of the evolution of the dark universe.
Yeah. So Euclid is more on the dark matter, dark energy side of things, trying to really do a survey and map out sort of gravitational effects and figure out where all of these different things are happening and where they've been happening. So JWST is sort of more like, it looks at a lot of things, but it does it in infrared. And Euclid is more trying to get this large scale structure of the universe. So
what I'm expecting from JWST is less pretty pictures and more significant scientific results. One of them will be to have a confirmation or not of the presence of these biological signatures around K18b. I think they requested time to observe this planet again in transit. So adding more data will increase the signal to noise and hopefully confirm or not the presence of this biosignature.
It might. I interviewed him on a SETI Live in November, I think, and he said that it is a very small signal. It might not get teased out any further than it has.
Okay.
But they are going to look and they're going to try and see if they can find it again. And at the same time, this is a very different kind of world that we're looking at. These are these Haitian worlds that are hydrogen ocean worlds. And so, this is the first one that they've really looked at. So it could also mean that they could look at more of them. And if they start to see a pattern, then we have something else we can take a look at and say could be evidence.
Yep.
So it's the start of something big, I hope.
I hope so too. I mean, the detection of a biological life on another planet, it's something big.
Yeah.
That's confirmed.
Yeah.
Okay. LSST, Very Rubin Telescope.
Yeah.
8-meter class telescope in Chile that's going to observe the entire sky three times per week and produce terabyte and petabyte of data. So why are you excited with this project?
I think if you combine the LSST, the survey part of this, with sort of like the data that Gaia has collected, we're going to have so much information about everything that's in the sky. And because it's going to be doing it on this routine basis, we're also going to be able to sort of like map changes, which means if there is that planet 9 out there, right, we could find it from this, because if it's reflecting starlight at all, sunlight at all, then we could see it and we could see a change and something move. So the hope is that we're going to find a whole lot of new objects out there because we're going to be able to see these changes constantly.
Yeah, and it also will change significantly the way we do astronomy. I mean, there is a field of astronomy we call time domain astronomy, which consists simply in looking at things which are variable, transient in the sky. It could be anything. It could be a nova, supernova. It could be a satellite passing by. It could be an alien spacecraft. Why not? Or laser communication. So with this type
interstellar asteroids.
Yeah, exactly. With this type of telescopes, we will be able to see more of those. They're expecting to be able to detect 2 million asteroids in less than 3 years. We know only 1 million of them, almost in the 20 years of observation or even more. So that's going to be a game changer. And astronomers will change the way they work. We, for instance, at the Unistellar, we have now a system that alerts our citizen astronomers when something happen in the sky. Right now, we're using the ZTF survey, but we are ready to, as soon the LSST has its first light and start its survey, to be able to do the same with LSST.
Yeah.
So you will receive notification on your phone when something happens in the sky, and you can observe it.
It's massive. Cool. It's going to be huge, and I'm definitely, that has been on the list for a while. Obviously, the pandemic set that schedule back a lot.
So hopefully this year will be the first light of LSST. It was supposed to happen in July last year, I remember. So it's slightly delayed, but it's going to happen. It's a ground-based telescope. Those always happen. Yeah,
and it's pretty much done. So it's just finishing it off. Hello, Ron in Louisiana. Nice to see you.
We have someone from Perth, Australia, joining us as well. Something happened with my computer.
Oh, there we go.
Here we are. Okay.
Mexico.
Kosovo.
There we go. Yeah.
Okay, we have a lot of comments. We have to scan in a tiny window through all the comments. Welcome. We are talking about what's going to happen in the year 2024 in space. So we talk about telescopes. Let's talk about one telescope we have here at the SETI Institute, Laser SETI. So Laser SETI is a telescope designed by the SETI Institute. Researcher like Elliot is basically designing those telescopes, and they build stations. There is one in California, one in Hawaii. And the goal of this station is to detect laser pulse from extraterrestrial civilization who wants to communicate with us, right? So what's the status of Laser SETI now?
So he's in the process. Elliot is the PI on this, and he's in the process of building what 10
yes.
10
maybe
total?
11.
Is it 10
maybe 11.
total or yeah? So there's a lot of 3D printing involved, and if you go online, he has a Facebook page for Laser SETI. We've linked to it before. You can follow his blog there, and he updates on what he's doing. But yeah, so they've been printing parts for another 8 or 9 observatories.
Yep.
And they have places where they're planning. They've already mapped out where they're going to put them. So it's all around the world.
So I saw a map recently because I talked to Elliot regularly about this, where he has stations in different locations. So it is not 100% confirmed, but it may be possible that this year we had a 3rd station that will be in Arizona, and maybe a 4th one in Canary Island, and maybe in the Arabic Peninsula. So this is something we are discussing at the moment with our partners, but we hope to extend the network slowly and get more stations and more eyes looking at the sky to see whether or not those aliens are communicating with us.
Yeah, so
we don't know until we search for them, right?
Yeah, exactly. And so follow his blog for further updates, and we'll keep posting about them as well, and maybe have him back to talk about it later on in the year once we know when that 3rd one is actually going to be operational. So.
And then Unistellar, since we're talking about telescopes, so we have an announcement in a few days, in 3 days, January 7th. I cannot tell you what it's about, but it's something cool and something nice. That if you follow Unistellar, we know that we design telescopes for the general public, and you can also participate with this telescope to our citizen science campaign here at the SETI Institute. We are running still the citizen science campaign. We have very cool results. This year is going to be an interesting year because we're planning to publish some articles on transiting exoplanet that we confirm detected by tests, which has been confirmed by the Unistellar network. But there is something bigger coming in January 7 at 5 p.m.
Yeah, so stay tuned. That's going to be exciting, and we're looking forward to that. And then you'll be talking more about that on a SETI Live next week.
Yes, apparently I just found out that I have a SETI Live next week to talk about it. I'm going to CES, but I'm also doing a SETI.
Exactly, and it'll be at a special time. So this will be on Wednesday next week, which is the 10th at 8 a.m. Pacific, 11 a.m. Eastern. So keep an eye on the socials for when that gets scheduled. It won't go up until after their press announcement, so it'll be a few days. But just to give you guys a heads up, so that's coming.
Well, that's perfect transition to talk about what we can see in the sky.
Yeah. So, so there are things that you won't need a telescope for this year.
I'll let you talk about this one first then.
Well, this is it's I guess kind of the elephant in the room. It's the big thing happening this year. We have a full solar eclipse happening that will be visible from much of North America, which is a big deal. We like to make a big deal out of these, and it follows on the heels of last year's annular eclipse, which we covered and did actually a pretty good job for all of the technical issues.
You were amazing.
You did what you could with where you were, so but it was really good. And this time we're gonna do it all again.
Yeah.
And we're gonna have a full solar eclipse this time. So
it's gonna be a full one. That's why it's a big deal. I mean, we often say, "Oh, it's another solar eclipse," but a full solar eclipse is something that people should see at least once in their life.
Absolutely, absolutely. I still remember the one I saw when I was in high school, and it was amazing. And it was another one of those ones where I didn't have to travel; it was just right there where we were. So we have maps up, but you can go just about anywhere on the internet. NASA, Earth, Sky and Telescope. Everybody's got maps of where the pathway of totality is, and of course, totality is where you're really in the shadow, and you will actually get that full eclipse effect. But there will be bands where it will be that partial eclipse on either side. So you will get to see some of it. Pretty much no matter where you are in North America. So that's really exciting. And we are planning some big events around that.
So we're going to travel around the pass. Some of the Unistellar station will go there. And and do a live and invite people.
Where are you going to be?
So I'm going to be in Austin probably.
Okay.
And we have one member of our team is going to go all the way to Toronto. And there will be people in between. So
Yeah. So
We're
it's
planning to have 4 stations or 5.
and then of course we'll have people from the Interstellar Citizen Science Network itself jumping in and hopefully being able to share their sites as well. So yeah.
We just need to hope that the weather will be nice.
At least it's got to be nice somewhere, right? It's got to be nice somewhere.
But it's part of astronomy to have hope, and then there's nothing you can do. Huh?
Just don't be near one of my friends because she's known for bringing clouds even to the most dry areas. So
another big event in my mind is the comet A3.
Yeah.
So the real name is Tsushinshan Atlas.
Okay.
So this is a comet that was discovered in 2023, so last year, and going to be extremely bright in September, just before it passes between us and the sun. It should be visible with a binocular, but then if it survives the passage close to the sun in October, November, it will be extremely bright in the sky, based on the prediction. Of course, comets are very unpredictable, so someone's going to use this video probably in October to making fun of me because it may not be a very impressive comet.
We've been waiting for like that comet of the century for
more than a century. No.
Yeah, pretty much.
Now this one is going to be as bright and as beautiful as Hale-Bopp and Hyakutake.
Okay.
1995, 1996.
You heard it here. It's going to be as bright as comet Hale-Bopp.
So yeah, you need to get ready for this one, to get some binocular, at least a telescope to observe it. It's kind of cool to see such a beautiful comet in the sky.
Yeah, and if it does become visible with the unaided eye, then it's always amazing. I mean, I literally pulled over to the side of a freeway once in the middle of the night to look at a comet and just sat on the hood of my car because it was gorgeous. And you're
one of those.
I was one of those.
All right.
Colorado was good for those kinds of things.
Let's see if we have questions. No?
Yeah.
All right.
Let's see. So
let me Google this one.
How many lunar eclipses, Mikhail Larson is asking, how many lunar eclipses will we see during 2024 if we are in the right place? Lunar eclipses.
Oh, I don't know that.
Oh, lunar eclipses.
It's typically 2 to 3 per year.
Yeah, so it usually is. I have not looked that up either.
It's Franck 2 to 3 per year.
Franck is looking that up. And while he's looking that up, I'm going to scroll through some more. Let's see. Could we? Oh, okay. Let's see. Miguel Lopez Medina is asking, could we conclude that the landing spot for VIP rover will be the same or close to Artemis mission landing spot? I guess you mean the Viper rover?
We don't know.
We don't know.
Because we have not been landing a human being on the moon for such a long time that I'm not sure it's a good idea to take the risk of landing on a place which is so
remote, difficult. If you're at the South Lunar Pole, you're going to have communications issues. That's why China is sending a satellite with one of their rovers, because that's a big problem. You're on the far side of the moon, and you're trying to basically send a signal through it to Earth. It doesn't work very, very well. So, I don't think any decisions have been made on that particular landing spot. Artemis 3 is even, I'm even more skeptical about Artemis 3 than I am about Artemis 2.
Yeah, because there is rumor that you may not land. So.
Yeah, exactly. So have you found your...
No, not yet.
Okay. Ivar Brower is asking, will Phobos be a rubble pile or more solid?
That's a very good question.
That is a very good question. It is theorized that Deimos and Phobos, well, there's been a few schools of thought over the years. One is that Phobos and Deimos were separately captured asteroids. One is that Phobos and Deimos were the same body captured by Mars and then somehow interrupted gravitationally and pulled apart. Phobos is the one spiraling in, right?
Yes.
Yeah. So Phobos is spiraling in, and in several million years will basically get broken up. I'm not expecting a rubble pile just because I think these are slightly bigger than the rubble pile asteroids.
Yeah, but if they made from this dislocation of bodies before, it would be
No,
also,
I mean it's
and
a really
and the craters have this kind of weird ball shape, which suggests that it also has kind of rubble pie structure.
so we'll find out. I hope.
That's the reason we're sending spacecraft over there.
Exactly. So that is definitely one of the big questions: is what will we find when we get a sample?
So Eclipse, there is 4 eclipses in 2024. The first one is in March 25th, 2024.
Okay. So 4
4
lunar
world,
eclipses in the world. Okay. Hey, Rachel. Rachel was in my internship cohort. So hi there. When are we going to Europa? So that launches in October 2024.
So the arrival is typically 8 years. I can check exactly, but it's roughly that.
And one of the PIs on that, of course, is Cynthia Phillips, who used to be
Mhm.
here at the SETI Institute, and Rachel and I both know her because she was one of the coordinators for the REU program at the time.
Yeah.
So very excited for her, very excited for this mission. So maybe that's our in. We should talk to Cynthia.
That's exactly what I'm doing. Arrival date April 2030.
April 2030. So wild.
Aye.
Europa's plumes. Ivar Brower is asking, what will they consist of? Well, we actually kind of know what they consist of.
If they exist, yeah.
Well, I mean,
there is still this controversy whether or not those are real plumes. Or
really,
yeah. I mean, there is still some people who claim that it's not. The signature of the plumes is not obvious. But anyway, so assuming that the plume do exist, they detected hydrogen OH in UV, so they assume they were made of water specifically.
Okay. So the question is, what else is in there?
Oh, but we don't.
Yeah,
That's exactly. Why we're sending a spacecraft. You find out if there is some salt, and if there is salt, maybe there is also amino acids and stuff like that. That's the reason we send the spacecraft over there.
Exactly. Let's see. Allie the Pretty Gator. That's a great channel name. When will there be exploration of Uranus and Neptune? From your lips to NASA's ears.
Go ahead. Try and make a prediction.
Well, this last round netted us 3 Venus missions. 2/3 of which are in trouble. And that was what, 2022 those were announced, and we're already wondering if they'll happen. We have the Mars sample return mission that is probably going to eat up the budget. So I'm thinking Uranus and Neptune are at least a decade out before we even start talking about planning anything.
The problem we have is also that the more we spend with time talking about it, the more distance are the planet Earth and Uranus. So the more difficult it will be to go there.
Mm-hmm.
So basically, if we want to send a mission to Uranus right now, we have to do it right now. I mean, we have to design the mission and launch it in the next year, if I remember, something like that.
Something like that.
Because then it would be too complicated to go there. So NASA has not been able to even get a budget this year, but not because of them, but because of the federal government. So I'm assuming that a mission like that is a bit too complicated for them to put in place.
I think so.
So my hope is that another country does it.
We did have some proposals during the round where Venus got selected, and there was one Neptune and one Uranus, and they were both obviously not picked. So,
and we don't know why. In fact, that's if there is a billionaire watching this show and wants to do something significant for humanity, it's the time to launch a mission to Uranus and Neptune. And we're not talking about $1 billion. You can do something for much less. Like just being able to go there and to orbit or to fly by with a better instrument that Voyager had will be extremely useful. Yeah,
it'd be a step up.
And the reason is because we know that there is a lot of planets like Uranus and Neptune in the galaxy, so we need to really truly understand those planets to understand those exoplanets and how they form.
Yeah, those Neptune-sized worlds are incredibly common. And then, of course, we have the sub-Neptunes that we don't have here, but getting a grasp on at least the Neptune-sized ones would help. And they also have moons that, again, host these subsurface oceans. Mm-hmm. So it would be really nice to finally understand what's going on there. I mean, Uranus and Neptune have tons of moons as well. So, there are a lot of possibilities.
You want to try this one? What could we offer to make it beneficial for alien intelligence to communicate? What's in it for them?
Well, I think it would be the same things that it would be in it for us, right? Like contact would be a big deal for anybody, finding a new civilization, finding a new life, a new biology,
a new genesis
would be good for any other civilization out there. So I would say that it would be the same benefits.
Yeah.
It would be that knowledge that we're not alone and there are other creatures out there. And if they already know that, then they can say, oh, here's another one. We can add that to the database of places life has formed,
And my answer to this, which is not a scientific, pure scientific answer, is that if a civilization finds that there is another intelligence in our galaxy, they will realize that they're not an anomaly in the evolution of species, and that intelligence is something that has a future as well, because we may be slightly more advanced than them, or they may be more advanced than us. So that means we have a future as a species, as an intelligent technological civilization. That may help us to calm down a little bit and focus more on making this world better and this civilization better.
Oh, I like that. There's our pull quote for the week.
Now we're gonna skip Artemis 3.
Some rando, that's an excellent name. Is the Earth's radio bubble detectable at any significant interstellar distance by any type 1 or type 2 civilizations? And the answer is yes. I believe it's within 100 light years.
Yeah, 100 light years we can detect that.
Yeah.
And we don't really know what will be the technological advance of a type 2 civilization, if you're talking about Kardashev type 2 civilization. So the type 1 civilization should be able to detect a cell phone 100 light years away from us.
So yeah, absolutely. Not. All right. Why is everyone aiming at 2030? Oh, well, it's just a matter of timing.
Any more? No, I want to answer to this one. Any more news on someone called Musk? I don't know this person. Attempt to put humans on Mars. Well, no, I have no news because I think this person has been extremely busy being on some social media platform instead of following his dream. So I don't know. Yeah, that's all I can say right now.
That's all we have. We have no more news on that. If you want to ask me about X, I can probably talk about it, but no. Well, that's kind of, I think we ran through the questions.
Yeah, we went through all of them, and it's already 45 minutes almost. So.
Well, yeah. So we did go over, but that's okay.
Any question we forgot interesting? Yeah.
No, I think we're good.
I think we're good, huh?
Yeah.
So we have some questions for you.
Yeah. So if you are in North America, and we saw that there were quite a few people from different states, are you planning to travel for the eclipse? Are you going to go out and try and witness the eclipse? And if you're not in North America, will you be trying to watch it online? So let us know in the comments if that's the case, because I'm kind of curious about how many people are going to make an effort. Yeah. And you had another question for them as well.
Yeah. We probably forgot something.
I'm sure we did. There was a huge list.
we basically went through a long list and we cherry-picked the thing that we thought was the most interesting. But it's very likely we forgot something very obvious. And if that's the case, let us know and we will take the time to answer to you in writing, or maybe make another short video explaining to you what we think about Artemis 3.
Yeah, and let us know. Also, let us know in the comments if there are any videos you want us to do this year, any topics you want us to cover, because we're already scheduled out through January, it seems, and working our way into February. So keep an eye on our socials for the upcoming SETI Lives.
And we're gonna do more videos in person like that.
Yeah, Franck is getting me to come into the office more often, so you'll see more of us together like this.
With a better background next time.
Oh, well, this is nice.
Aye.
But I think I may have to bring in the better camera. All right, everybody. Thank you so much for joining us today. We're really happy that you were all here. Thank you, Franck, for for helping set this up and for hosting with me. Always a pleasure.
Always a pleasure.
And this is
Beth.
fun to do it in person now. So, and, thank you everybody for watching, for asking questions, and, do the thing on the socials where you subscribe and share and like and all of that, because we could really use some social media boosts this year. So thanks everybody for watching. Don't forget to check out our website, SETI.org, and you can find more on all our events and news there. So everybody have a wonderful 2024.
Bye-bye.
Bye.